Welcome back, guys. Today we are going to solve a problem in which we have to move the zeros to the end of the array. So before starting out the solution and the thought process, first let's see what is the input and what is the output we have to give. So here in this example, we have this nums array in which the array is 0, 1, 0, 3 and 12, right? So what we have to do is we have to take the non-zero number in the front, that is 1 will come first, then 3, then 12, and then we have to move all the zeros to the end of the array. That is the problem which we have given, and in this format we have to return our answer. Correct? So now before coding, let's see the thought process, how we can achieve this solution. Now, coming to the thought process, as we have to move all the non-zero elements to the front, right? So, the most obvious or the brute force solution can be we can store all the non-zero elements in a temp array, right? Let's say we can loop through the original array and see. First element, it is a 0, yes, so we can ignore it. Now coming to the next one, it is a non-zero, yes, so we can store it here. Now again a 0, so we don't need it, we can ignore. Now the next one is 3, that is a non-zero, so we can store it inside a temp array. Now again 12, that is also a non-zero, so we can store it in our temp array, right? So till now we have made a collection of all the non-zeros inside our temp array, right? Now what we can do is we can just simply iterate through this array and start placing our non-zero elements to the front. That is, first element is 1. So instead of 0, we can place 1 here. Now the next element is 3. So we can replace this 1 with 3, right? Now the next element is 12. So we can replace this 0 with 12, right? So we have placed all the non-zero elements to the front, right? So our resultant array will look like this now. 1, 3, 3 and this 12, and again as 3 and 12 are remaining, so 3 and 12, right? Now what we can do is, as we have placed all the non-zero elements to the front, so now we have to make all the remaining elements as 0. How we can do that is we can check the length of this temp array, that is 3. So we can start from the third index, that is 0, 1, 2, 3. So we can start from the third index, and after that whole remaining array we can make it as 0. That is, this 3 we can make it as 0 as we don't need this 3. This 12 also we can make it as 0. Now we can see the resultant array is 1, 3, 12 and 2 zeros. That is the answer we should give, and that is asked in our question. Correct? So this is simply the brute force solution we can give and achieve our output. Now talking about the space and time complexity, as we are iterating through this array and assuming the length of this array is n, so the time complexity will be O of n, and as we have used this extra temporary array for storing the non-zero elements, so in the worst case the space complexity can also be O of n, right? Although this is a brute force solution, as we know, and there's still the scope of improvement and we can optimize it further. So Now let's think how we can optimize it further. Solution. Till now, we iterate through the array and store the non-zero numbers inside a temp array, right? But now what we can do is instead of storing them in an array and putting them again in the original array, what we can do is we can iterate. While iterating, we can try to place non-zero inside the front, right? So in the optimal approach, our basic idea is instead of storing first and then placing to the front of the original array, why we can what we can do is we can directly put the non-zeros to the front. So only thing we are skipping now is, or we are trying to skip is storing them in a temp array, right? So what we can do is we can iterate through this array and start. So as now we are placing, before we start, what we are exactly trying to do is whenever we find a non-zero, we try to place it in the front, right? So what does it mean? That a non-zero will exist at a certain position and we have to place it at a certain position, right? So that means we need a two positions at a time. So what does it mean? That is, we need an extra pointer variable to store the non-zero position and the current element we will have through the iteration, right? So let's take a variable as I and point it to the here, right? This is our pointer which will indicate to the front elements. Okay, now we are initializing our I from 0 and now let's try to loop through the whole array, right? So first element is 0. As it is 0 and it is and we are trying to search for the non-zero ones, so we can completely ignore this, right? Now our j will move to the first. Now as this first index is 1, so that means we can place it to the ith position, that is 0th one. So 1 will get here, right? And we will increment the I. Now I will point to this index, right? Now again our j will move further as now this element is 0 and we don't need 0, so we can ignore it. And again we will move rj as we are looking for the non-zero elements only. Okay, basically our target is to move to the all the zeros to the front and all the rest of the zeros we can ignore. Now we are getting the 3, that is a non-zero, so we can place it to the front to the ith position, that is here, right? So instead of 1, what we will store here is 3, right? Again we will move our jth pointer and it is a 12, that is a non-zero, that means it needs to be placed in the front. So after storing 3 here, our I will move here, that means we can store 12 here, right? Now in the previous approach, that is the brute force one, and the current approach, only difference is in the brute force one, we are trying to store the non-zeros, and after storing, we are trying to place them in the front, right? But in this approach, while iterating itself with the help of another pointer, we have placed the non-zeros to the front. And if you now see the resultant array, it is 1, 3, 12, 3, and 12, right? And if you remember, this array is exactly same that we got after placing the non-zeros towards the front in our brute force approach. Now Again, the same thing, as we know, we have placed our non-zeros to the front, and this I pointer will tell us from where we have to place our zeros. So I ended up here. That means from I plus 1 to the n, we can iterate one more time and place all the elements inside this condition as 0. That means this 3 will become 0, and this 12 we can make it 0. And this I, we know already that we have placed till here, that is I was 2 here, right, in this iteration. So I plus 1 will be 3, so 0, 1, 2, and this is 3. So from the third index onwards to the last index, we will make all the elements to 0. That is, now our resultant array will be 1, 3, 12, again 0, and one more 0, right? And this is the actual output what we are trying to achieve. And now if we talk about the space and time complexity, so as we have iterated through this array and assuming the length of this array is n, so the time complexity will be of n. And here in this optimal approach, we have skipped the part of storing the element in the temp array, and we are just using the two pointers, that is I and j, and assuming they are taking space of O of 1. That is, we are not using any extra space. So this constant space and of and time complexity we can have, and it is the optimal solution that we can do. Now we have understood the both brute force and the optimal approaches. Now we will try to code it up and see how the solution works. Now we are back to our code editor. Let's implement what we have thought till now. So before we start, we have to carefully understand what we have given and what we have to do in our program. So we have a function, this move to 0, and it is taking an input parameter nums, which is our array, right? And we can read it from here as well. And in the return, we have to return nothing, and that means we just have to modify our this nums array without returning anything. So now let's start. As we know, we are doing this approach with the help of two pointers. So let me initialize my first pointer as I equal to 0, right? This pointer will help me, is used to place elements in front, right? Now what we can do is we can simply loop through our array and do, that is j is less than nums dot length, and again j plus plus. So what we know is we only care about the non-zero elements as of now. So if nums of j is not equal to 0, that means we have to place that at our ith pointer, right? So what we will do is nums of I equal to nums of j, and as we are stored it in our ith pointer, we can simply increase the I by 1, right? So till now we have placed all non-zero to front and moving all zeros to n is pending, right? Now we know that all the remaining elements from ith plus 1 position, right, we will have the zeros. So We will start our loop, okay, and once we start our loop from, let's say, I to the whole remaining length of the array, that is nums dot length, and what we can do is we can simply do nums of k as 0, as we have to make those elements as 0, right? Now let's run this program and let's see if there are any errors or something. So the base cases case 1 and case 2 are passed and accepted. Let's try to submit the solution. See, our code is submitted successfully, and we know after understanding, writing the code is super simple, right? So we should always focus on understanding the thought process and our intuition. Hopefully, you people have understood this problem and the solution. And if you guys have any doubts, you can ask me in the comment section. I will be ready to help you out.